A good way to start a meditation is by counting out the components of your breath to bring awareness to the cycle of your breath. For example, I like to breathe in for a count of 5, hold my breath for a count of 2, and then exhale slowly for a count of 7. Then I repeat that over and over. And I do that a lot when I'm trying to calm down, but also when I'm just enjoying the moment and trying to meditate. So let's try that for a couple of breath cycles. First, exhale. Now breathe in for 1, 2, 3, 4, 5. Hold 1, 2, exhale 1, 2, 3, 4, 5, 6, 7. Breathe in for 1, 2, 3, 4, 5. Hold for 1, 2. Exhale 1, 2, 3, 4, 5, 6, 7. Although this is a 10-minute recording, I will not be speaking for most of it. There will be long periods where I will pause just to prepare you. If you aren't sure what to do, then the breathing exercise that you just learned is a good thing to do. So, okay, here we go. First, there is nothingness, or at least we cannot see anything because it is completely dark. Now, the absence of nothing is one. One is existence. It is identity. It is definitional. A single point. But a single answer can rarely describe all. Reality is messy. And that messiness is beautiful. The residuals capture that messiness. They are interesting. They are all that exists in the universe that you still don't understand enough to explain, or can't measure well enough to detect if you can explain it. One way or the other, the value of the residual represents chaos in your model. Chaos and randomness. We can see the final value of the residual, but by definition, we do not know what causes that result, that final value. There are at least one or more causes of the residuals, and I will present 2 to you: chaos and true randomness. Chaos theory posits that apparently random phenomena are sufficiently complex combinations of systematic, deterministic components. That is, chaos is not randomness. Chaos is order that you have not yet mapped out. For the GLM to be worth anything at all, this definition of chaos must be at least partly true. If this were not true, then the predictors in a linear model would offer no improvement in prediction over the mean. However, there is, or is there, also true randomness. Randomness that cannot ever be predicted because it is not caused in any deterministic way. Do you believe in it? Is it possible for any true randomness to exist? The residuals represent what we do not know. So are we seeking to reduce the sum of their absolute values to 0? Is that possible? We would certainly know if we achieved omniscience, because you're omniscient, so you know if you've completely reduced the sum of the absolute values of the residuals to 0. But until you achieve omniscience, until that moment of omniscience, you never know for sure if omniscience is possible. So it's the existence proof, or omniscience would be proven through its own existence and never known if it was possible until it was shown to exist. Anyway, so what do you believe? Do you believe in the existence of some true randomness in the universe, or none at all? In what proportion? If, including 0 for either of the two, but what proportion of the residuals in a given linear model would you ascribe and bet are chaotic, systematic, complex but systematic processes that just haven't been explained yet and theoretically could be explained? And how much, if any, are purely unexplainable, purely random processes that have no deterministic or systematic relationship? So let's think about that for a while paying attention to your breath, or to the music, or the visuals, or any combination of those things. Now we are coming to a close, but the final thing I will say about the question you are meditating on is that your answer to that question will shape your approach to statistics and really to science on the whole. Thank you for joining me in this meditation.